How does your phone recognize your face or predict what you will text next? Is machine learning the same as AI? Answering these kinds of questions can help us understand what is AI. Many of you might associate AI with androids or lifelike computers, but these examples only exist in movies. But let's get back to the basics of where AI is today. In broad terms, AI is a computer's ability to perform tasks that normally require human intelligence, like recognizing speech and categorizing visual information. AI encompasses a much wider range of mechanisms and is the general field that includes a subset called machine learning, which in turn includes deep learning. AI algorithms are all around us, from Face ID and digital assistants to online shopping recommendations and so much more. However, it is important to understand that AI is based on numerical calculations. This means that it does not know your face or what you will buy next. It only crunches numbers. So when an AI system unlocks your phone with Face ID, it starts by taking a picture of your face, which is composed by a grid of pixels. These pixel intensity values are the input of the system, which will then be used for calculations to compare the current image with the one stored before. If the values match up, it triggers a response confirming, "This face matches the one we know," and proceeds to unlock your phone. This is an extremely simplified example of a highly complex process, but it is important to remember that AI is an algorithm, and it only deals with numbers, no matter if they represent images, words, or stock values. But how can these algorithms know if the faces match or not? In contrast with other computer software, that each individual instruction is programmed, "If this happens, then do this," machine learning models extract patterns or implicit rules from data. This can be done through supervised learning, where the algorithm learns by example, using human-labeled data. In the Face ID example, one way to train the model would be to feed it with pairs of images, telling it this is the same person, or this is not the same person. And the model will then seek statistical patterns within the data to identify each person uniquely. Crucially, it's the algorithm, not the programmer, that identifies these patterns and establishes the rules which will enable it to recognize the same face in the future. Besides this method, there is unsupervised learning, where the algorithm has to find patterns without having the corresponding labels, and reinforcement learning, where the model does not learn through data, but through trial and error to achieve a specific goal. Most of machine learning models learn in a supervised manner, like decision trees, logistic regressions, neural networks, among others. Neural networks are so powerful and unique that they originated a new field inside machine learning, called deep learning. Inspired by the biology of nerve cells, neural networks consist of neurons that receive an input of numbers, process this input through a set of functions, and transmit it to the next neuron. By stacking layers of neurons together, this model can perform very complex computations with a very high accuracy. As we have seen in the facial recognition example, neural networks and other machine learning models can be used for computer vision to detect faces and other objects, which will allow self-driving cars to avoid obstacles. Text analysis is another application that benefits from the power of neural networks. Natural language processing is a subfield of AI, which uses linguistics to give computers the ability to process text and spoken words, allowing to extract information about the topic, the intended sentiment, or even predict what would be the next word in a sentence. This is one of the interesting features of neural networks. Once it learns the rules, it can work with these rules, creating text, images, and even music and art, following the same rules. But this can also bring previously inconceivable challenges. That's particularly the case with deepfakes, a combination of the words deep learning and fake media. Deepfakes can manipulate or generate visual and audio content that is almost indistinguishable from the true original. This fake content can help Hollywood productions make more credible understudies, but can also be used to spread disinformation or blackmail. Besides the potential use of such technology for malicious or even criminal purposes, there are also risks associated with the legitimate use of AI. For example, if the data on which the AI model is trained contains biases, the model will amplify that bias, which can lead to misrepresentation, especially for groups such as racial minorities or women. To have a good model, it is therefore fundamental that one has not only a sufficient quantity of data, but also that the quality of data can be ensured. AI, machine learning, and deep learning are all new fields for most of us, and are moreover rapidly growing. It's exciting to see what we are able to accomplish with these powerful tools. But we should also keep in mind that AI is not 100% accurate, and that there are risks associated with its misuse. The first step in working towards positive and conscious AI is understanding exactly the tools that we are working with, and by looking critically at the results before taking important decisions.